Is that better?
That's better.
Ah, okay. Yeah. So we're jumping in, talking about how science fiction informs the way that we design user interfaces for healthcare applications. And so this is the latest Star Trek med bay, and we have patient demographics, we have timeline and time information. There's a dermatogram over there. And then we get into other types of, here's Minority Report, and weren't they groundbreaking in how we thought about motion and how we interact with computer systems. And this is the first movie that I remember where they started showing transparent glass displays, which thematically is going to be a recurring theme. So here's some television series, the techno jargon in here doesn't matter, but what's interesting is the way that they're creating a minimalist design to display on glass displays. But if we scan out, again, they're thinking about walls, and they're thinking about environments where information is being displayed. And then we get into some more recent ones, and we can put a user interface on anything, put it on the health pod, or have a whole control room where it stretches, and we're not constrained by space. And so a thematic portion of all this is around smart glass and the material science that we use to make displays. And so a few years ago, after I had transitioned from the provider, healthcare, hospital side to working in industry, I ran across a concept video from Corning. And I encourage you all to check it out. It's called The Day Made of Glass. But they started talking about their product line of smart glass technologies that they could put into different devices. And they're like, we can put these interfaces into the mirror of your home. And I saw this and I was like, that's the kind of user interface that I want to design. You know, if people are going to be tracking healthcare at home, track it here. And I'm wanting to see how do I get a patient record? How do I get observations here? How do I get this data into advanced displays? So here they're like, oh yeah, we can take this smart glass and we can put it on a countertop. We can, and I'm thinking, well, I want nutrition orders. I want teleconferencing. I want my practitioner here. And they took that and took it into the workplace environment. And so this is like an ad agency or something. But I'm thinking, wouldn't that be a great control room for your hospital operations? I want to get teleconsults. I want patient information there. And I wasn't the only one who thought along this way, because they made two videos. The first was the sort of business one, but the second one, they were like, yeah, let's go medical. Let's go show how this would work in the clinical environment. And so this one was a key scene in it. And I was like, patient. That's a FHIR patient resource right there. That's a FHIR card. And then this was a smart exam room with a built-in display just embedded in the wall. And again, I was like, I want to get a FHIR resource from that device to that wall. And so it brought me to material design. How do we design for these kind of interfaces, and how do we make the components so that we can recompose them and put them on different types of devices? And how do we do that with FHIR? So if you're not familiar with Google material design, I encourage you to all check it out. Material design is a library, but it's also a set of design principles. And it's a little wonky, but it's about the intentionality about layers and colors and motion and communicating intent and function through those parameters. And this is a good example of a very basic sign-in screen, but there's some rich imagery here. And remember, I used to work at a medical illustration studio. So here's, they rotate through different images. And my thinking was, well, I want to replace that with medical imagery. I want patient education materials here. And I want some FHIR data here. And so that was the beginning of my sort of journey to start experimenting and prototyping on this. Doing a lot of research. Material UI is a library where you can get pre-rendered components that this is built with, basically. And you go to this library, and it gives you a big list of different components. So you're like, I want a text box, I want a card, I want a menu bar, and they give you examples, they give you code samples, and so forth. The one caveat is that this requires a technology called React. And why React? Some of you may have heard of it. It's from Facebook, so now we have Google, we have Facebook. React is really powerful because of its reusability and composability. You write these really well-structured components, and they get they have really great reuse. And so I started looking into this, and it was some really great technology, and I ran with it. And then obviously FHIR. You all are familiar with this. So what we have is we have three technologies. We have FHIR for data models, we have React for reusability and composability, and we have Material UI for design principles, how we're going to piece all of these things together. And just for context, the platform that I work with is a full-stack JavaScript platform. So it's called Meteor.js, and Meteor bundles a bunch of JavaScript technologies together. And then I've been working on a fork of Meteor, which we've made HIPAA compliant and FDA, and added FHIR and Material UI and React. So component architecture. We talk, like the FHIR community really does a whole lot of this, where it focuses on the data getting to the client, to the web, but then it kind of ignores what happens in the client. There's a lot of focus on this, not so much on that. But here's the thing. We could put in a static page. You could put a photo of clouds on it, and if it's receiving those FHIR resources, it could still be a Smart on FHIR app. I mean, you don't even have to have a user interface to have a Smart on FHIR app. I mean, this is like you can make it completely static, but that's not really what we're thinking about when we want to design interfaces. So what we're talking about is getting granular control of our elements, our components in our application, and creating some design principles that pull them together, and then hopefully adding the FHIR data types. And you put all these things together, and you start getting maybe like a patient card, like we saw in some of those design videos. Now then, how that works. So in React, they have this function, the component mount into the document object model. It can be as simple as this, and this is the model that a lot of people use, is you fetch data, you display it. Good for dashboards, good for tables, and so forth. But for forms, for interactive user interfaces, you have to start saving some state in the component and get this round trip. So the FHIR resource goes in, and then we display it. It gets put into the state, it gets displayed. Input comes back, it comes to the state, and then you might send it elsewhere. You can refer to this afterwards in the slides, but typically these are the kind of architecture diagrams that you want to see when building these kind of front-end user interfaces. And if it's more simple than this, you're probably not doing it right. This is the type of architecture approach that you want to see, and you can see like in this model, the JSON is basically our FHIR object that comes in, and then you have some state, you have actions, but then you want to see how the component render tree it gets put together. So I started, I did a whole bunch of this research and was like, well, let's give this a try. Let's actually run some FHIR resources into it and see how performative that we can get it. And so let's do some render tests. And this is my background from Medical Illustration Studio to give it a try. And so the render test that we're going to see in just a moment is comprised of a number of layers. And those layers, remember, we're talking about the design principles. And so we have a background layer, we have the glass transparency layer, we have the cards, and then we have the rendered data on top of it. So let's take a look at what kind of performance we can push out of React running with some of these FHIR resources. And so we got a medical illustration background. We pulled in a whole bunch of FHIR resources, some test data, and now we're going to start doing, we just did the privacy screen. We blurred the data dynamically, but we removed components. They slid in and out. We got smooth location movement. We went full screen there. We're moving it back, and all the time, every part of these components is doing 60 frames per second and is pulling it all together with our data types. The data types are somewhat static, kind of riding along, but I would suggest that not a lot of UI frameworks are able to handle this on the web. So this is all done in the web browser, and this is front-end web technology that can run on mobile devices, on websites, and get all of this pulled together. So we're gonna skip, there's more of it. You can check it all out in the slides, and whoops, can we go to the next slide? I'm stuck in my demo. There we go. Now it goes on repeat. So, what we just saw was 4 layers that each had a delta. They were adjusting height, location, font color, background color, blur, background video, and so forth. And we had that all dynamically updating in 60 frames per second. Behind the scenes, what you have is the FHIR data comes in and populates only one of those layers. And you have to design with intentionality around that. You don't just kind of drop the FHIR resource anywhere on the framework. The user profile is feeding into the selection of the background. The device state is saying whether we're in landscape mode or portrait mode, so the device state will also be adjusting the rendering. And then the FHIR data may go trigger other components, and those components may fetch data and so forth. And again, this is the kind of thinking that behind the scenes is what's happening on your phone or your tablet, but could also be a video wall, it could be a surface display, many other things. So component libraries. So this was the architecture that we've been working with. And with the clinical meteor, there's a GitHub repository which has, I don't know, something like 185 repositories in it. I've been working on this for about 3 years, and we developed out probably 250 plus components. We were supporting 63 resources to some degree, varying degrees of development, but most of them have a Meteor dependency, and not everybody is completely enamored with Meteor. It's opinionated, and other people want a more neutral approach. And so what I've been doing is I've been refactoring out the Meteor dependencies. And so this is the first talk first time I've given this talk, and we're introducing this Material FHIR UI library. It's starting off with normative resources only. So we have our first one. We got it working. We did the successful figuring out all of the dependencies, making sure that it's cross-platform so that it doesn't have ties to Meteor and so forth, and you can install it through NPM. So Clinical Meteor is the history of this project, and if you want to go dig in and be like, well, let's see here, is there a genomics component? Well, there might be, there is, but is it all up to date? Maybe not so much. But Material FHIR UI is the project going forward, and we're taking the components and we're going to be moving them into this library, which is now published on NPM. So yeah, that's the Clinical Meteor repository. It's deprecated going forward. You can dig in. Good luck, but going forward, we have the Material FHIR UI. It has best practice patterns, ES6 imports, exports. It's sort of future designed for the future, but it's a work in progress. So code patterns, and what are the actual code patterns for implementing some of this? This is, I think of it as the holy grail of 3 years of work to get to this syntax. We have the Jane Doe resource, which is just a FHIR patient, and you've all seen this elsewhere. But the React syntax, if you're not familiar with it, it's HTML-like. It's not pure HTML, but it's reminiscent. And what we're wanting is this like patient card, and this has been updated since it's now just patient card, not hello. The patient card, we just want to be able to drop the patient and just drop the entire resource in and have it render out. So, and importantly, we want this to be composable so that you can reuse it. In the component definition, we define two things on the state. We define the patient data, where we basically just drop in the FHIR resource, but then we also have the form data. And the form data is really important because the name of the game is hydration and dehydration. And this is going to get a little wonky and a little algorithmic, but the idea is that the FHIR resources come to us in these big trees. They're tree structures, but most of the rendering tends to be in arrays, and they tend to be flat lists. And so what we're doing is we're picking leaves from the tree and making an ordered list, and we call that dehydration. And on the return trip, when you've clicked some form elements and you want to save and update back, that's hydration.
Do you send everything to the client, or you actually do the? Sounds like you do the hydration on the client side rather than the server side.
Correct. We're doing it all on the client side. The question was, do we do the hydration, dehydration client server? And it certainly could be done on the server. We implement within the React component itself. So what does that look like? That looks like having a function, dehydrate FHIR resource, and we drop the patient in, and then just a series of we're plucking leaves from the tree to flatten it out. And if you can get this process rock solid, then your application becomes performative. And if you don't have this, it's going to be death by 1,000 cuts of this one adding 10 extra milliseconds, this one adding an extra 20, and it all slowing down until it's not performative. We have like a 200 millisecond window of user experience where if it's not rendered in that amount of time, people are like, oh, it's sluggish, it doesn't work. So this is the name of the game, getting this down really solid. And we do it on the reverse. We are now taking the form field, or the form. We're kind of parsing through a switch statement and looking for like which one, and where we map it back into the FHIR resource. So this goes the other direction. In both of these, we're using some defensive programming techniques. In particular, if you don't use Lodash, I encourage you looking into it, or a similar kind of library, and the get helper function. Get and set, they're named in a generic way, but these two functions have a really specific tree navigation process. And so what they do, they navigate a tree path efficiently and safely. Safely in that they can also define a default value. So you can go in and say, get FHIR resource, name 0 text, and it's going to parse through your FHIR resource, and if it doesn't exist, you can specify return a blank value. And by having that defensive programming technique, you can have any FHIR resource come in, and if it doesn't have the field, it will default safely and correctly, and you don't get any of the micro performance degradation. So I really encourage you to look into these helper methods, and yes.
Should it be also on the other path? So what would happen if the next information that I would need would be number 8?
Yeah, so number 8.
Work in the same way.
Correct, and that would be, so look at how patient display is we go there and its default is a empty string, but if we just looked for patient, then its default would be an entire object. And so that's how you would do a patient reference, a reference object with display. So yes, absolutely. If you need to go to another level of the tree, get is completely able to do that, and it's very powerful to just do so. So there's some other details which are a little less interesting. We go through, this is a render function. We grab form data from the state, then we assign it to the material UI components, assign the values. In particular, we want to kind of look at the value and on change, and we use the get on the one side, and then on the return, we're going to go call the set. We do a similar process with the form data so that we can store partial state changes. So you've edited the field, but it hasn't updated the server or something else. So that's an important use case. And in that cyclical diagram, you've got one of them updating the user interface and the other for outbound. So there's two use cases that look similar. One's updating form data, one's updating the patient data. Then we expose events through prop types. We also have some typing down at the bottom, which is sort of a refactor path towards TypeScript. This is all leaning in that direction. And so let's see a little bit of this in the code sandbox.
Sorry.
Yep. So if anybody wants to go take a look at a live demo, I think the idea is just to kind of wrap this up with a little bit of a live code demo. And are we? So there's a Jane Doe, and here we have the patient data, and I can go in here and Sally or Amelia, and we're updating in real time. But the composability is what we're interested in. So if I go here and put in a couple of these, boom, look at that. And now we could make a patient list. We could come in here and clone this user. That crashed because we have two Jane Does, but we do Sally Doe and Sally. And just like that, we're getting to a sort of design pattern where we're using composable and reusable resources that can be compiled on the fly, and a next step might be to go in here and start fetching live from one of the Happy servers. And I dare say that in future versions of this talk, we're going to see Code Sandbox now be able to people start experimenting, say I've created this component, share it, test it against a live Happy server, fork it, share it, and so on and so forth. So that's most of my talk. Are there, I think I'm going to open it up to questions at this point.
Yeah, you mentioned fetching data in the back. Are you talking specifically about using just the JavaScript fetch function, or have you run this with the like the smart JavaScript client embedded in it as well?
So those 250 components that I talked about, we use Smart on FHIR extensively with them. What happens is it pulls over the FHIR resource, and then what? And this whole talk is about the and then what is how do you, and importantly, talking about maybe there is a something afterwards. Maybe you're relaying it to a different system. Maybe you're rendering a component that's FHIR aware. And so yes, it's all Smart on FHIR compatible. All of this would be a simple HTTP GET to a FHIR server.
Just wondering, obviously, you bet your visitors on this in a way. What do you like about Material-UI versus other React component frameworks that implement Material UI?
Material UI, as far as I was aware, was one of the first to do it, and they have a very large user base. So it's got 10,000 stars, it's got active development, and it was mostly a circumstance, but also you get on GitHub and do the how many stars, how many forks, and it just seems to have the most active community and the most full-fledged implementation. So, and the whole project, or at least Material FHIR UI, has been this idea of let's replicate that library, but with FHIR components. And going forward, we're going to be doing components for all the resources, particularly as they go normative.
Have you tried to mix sort of components? That's the big flexibility of like whether you use React and Poly?
Absolutely. Absolutely. So in a clinical media framework, we mix and match all the time. It is absolutely composable. What we do find is that the React components are way more composable. Like you can have a backbone application and take React and like on this one page or this one DOM element, expand out that everything within this is composable React, but then all the rest of the stuff, all the backbone is kind of static. But when you build your entire app with these React components, becomes very maintainable, very like super code reuse, and really a joy to work with. I spend a lot more time focusing on clinical problems than on technology problems using this framework and this approach.
At my work, we use Angular, so we use a lot of TypeScript. I was wondering if there's any resources out there for like models, for data models on the front end for TypeScript.
Yeah, so there is a FHIR TypeScript library, and we're going to be pulling that into the material FHIR UI library over time, and absolutely. And so most all of React with the prop types is kind of set up to lead in a refactor path towards TypeScript, I think.
You mentioned using Redux for state management.
Yeah.
I know you've been working on this for a couple of years. Has there been a thought about moving to prop building or context API using Redux?
Yeah, so actually, disclaimer is I personally don't use Redux. We use Minimongo, and this example is kind of designed so that it doesn't require state storage. Your state storage and your client data storage strategy has some implications on how your implementation is going to happen. So that's a whole sort of opinionated conversation that I've tried to avoid in this talk, but yeah, it's something that you have to figure out your strategy for. Yes, please.
Okay, so follow-up on that is you have actually GraphQL on
Yeah.
your diagram, but you didn't talk about.
Yeah.
Have you thought of like using GraphQL to reduce the client-side load?
Yeah, so I think.
What's your experience?
Yeah, so we have. We did an early little tiny prototype with GraphQL. I think that it's still 5 years out. I think that it's healthcare is still only getting to version Web 2.0, and it's more like Web 3.0 or more. So I think it's a bit. I think it's not quite yet. And the other question is do you really want to do that? You're locking your client down to a minimalist amount of work, and it doesn't have the capability of relaying or of doing, I think, some advanced functionality. So people are going to have some real architecture decisions about whether they want to go down that road or not. Other questions?
I would expect in general that UI libraries have a shorter half-life than data libraries because they innovate and deprecate more frequently. And has that created, like, especially when the data libraries are like health systems, slow. Has that created like any sort of noticeable conflict, or how do you plan?
Yeah, so it's a great question. Is half-life and the turnover rate of UI libraries, and I would suggest that the FHIR data models are going to anchor that, and also the material design is also anchoring it. And I think that these two things are going to cause some long-term stability in that we know what the data model is. It's gone through a data governance process. So if it's not changing, we can actually invest in that UI library and grow it beyond what the open source activist community is, what's shiny for the day. I think that there are some factors that we can create that will give it some maturity and some stability. Other questions? And I think that's time. I think, thank you for the talk, and appreciate it.